All right, let's take a look at this one. Another quadratic problem. Let's see. A tennis player hits a ball 1 meter above the ground with a velocity of 20 meters per second. When will the ball be at a height of 1 meter again? It cuts off the word again, but that's what that says. All right, so let's think about this and sort of think through what this is saying. So, 1 meter off the ground is where the tennis player hits the ball. The ball, of course, is going to go up into the air, and then it's at some point it's going to come back downward, right? Let's do a nicer, I don't know, something like that, right? And then we expect it to bounce and bounce and bounce and bounce, right? If nobody hits it back or stops it from bouncing, that sort of thing. Okay. And so at some point, it's going to be at 1 meter again off the ground, right? It starts at 1 meter, and at some point it's going to be 1 meter off the ground again. And that's the question, is when is that going to happen? So if we think about this in terms of if this is our x-axis here, and if this is our y-axis here, then this is the time. So at 0, right? It is 1 meter off the ground. So this is the height. And the question is, what's the time going to be when it's 1 meter off the ground again? So that helps me to think through a problem. I'm giving you a visual, and I'm trying to show it to you on even an XY graph just to kind of see that as well. But one of the points that I'm making is that my picture is not beautiful by any means. It's not pretty. It's not to scale or anything like that. And yet it helps me to sort of visualize what's happening here. I didn't have to even have to draw like a little stick person and the whole, all that stuff, right? I didn't need all those details, but it just kind of helps me to think through what's happening. So I'm going to use that as I jump into the problem. This is the function and sort of a formula that you'll be given, right? You'll be given this value at the beginning, so you will not have to solve for that or anything. The V stands for velocity, so that's nice, right? That just means we're going to put plus 20t in the middle. The T, let me make sure this looks more like a plus than a T. The T stands for time, so time in seconds. So that's kind of nice. All right, so let me bring this down. So the height that we're looking to find, what we're solving is when it's 1. We want to know when it's going to be a height of 1. So 1 equals, let me bring this down, negative 4.9 t squared plus our 20 t from the velocity plus the height at 0 seconds. Well, the height at 0 seconds, it tells us is 1 at the beginning. That's right when they hit it. So that's at 0 seconds. So that's 1. Okay. So in order to solve this, it needs to be equal to 0. So I'm going to subtract 1 from both sides. 1 minus 1 is 0. And so I have negative 4.9 t squared plus 20t. And 1 minus 1 is 0. So that part goes away. Okay. So notice that you have a t value in both of these. So I'm going to divide both sides by t. And that leaves me with t equals negative 4.9 t, because there were 2 here and I took 1 out, plus 20, and it's just plus 20. There's not a t value there. Okay, so this is interesting. We factored out the t that was in common, and now we don't have a quadratic anymore, so it's not like we're going to do some kind of other factoring. 4.9 and 20, that's like, think of it as 49. 49 and 20 don't have any common factors. 49 will only divide by 7, and 20 won't divide by 7. So there's nothing we can really simplify there. But we need to figure out these solutions. We're still trying to figure out the time. It says when, that's time, right? So we're going to take these factored form answers and set them both equal to 0. So this means that we can say from here, t equals 0 and t equals negative 4.9. No, I set that up wrong. Sorry. T equals 0, and then negative 4.9 t plus 20 equals 0. Sorry about that. All right, so I'm taking this factor and saying, what if it equals 0? And then I'm taking this factor and saying, what if it equals 0? Well, t could be 0. In fact, we know that at t equals 0, when the time is 0, yes, it's up 1 meter off the ground. So yay, that tells us we're on track. Okay, that makes sense. The other time will be when the height is 1. So let's solve for t. Looks kind of funny, right? Think about it. We want to subtract 20 from both sides. 20 minus 20 is 0. So that's negative 4.9. T equals 0 minus 20 is negative 20. We'll divide both sides by negative 4.9. Now, I hope that you've got your handy dandy calculator. So I'm about to pull mine up here. And let's see, negative 20. You can do divided by, or if you have a calculator like this, you can just type it in as a fraction. Either way, you get the same answer. So if you had done division, it would work that way too. So this is about 4.08. We'll go to there. Okay. So t is about, and notice it's a positive, 4.08, right? That's approximately what we got. That is our answer. The time is about 4.08 seconds. That's how long it will take for the ball to be hit, go up into the air, start to come back down, and be 1 meter off the ground. About 4 seconds is the answer to the question. All right. I hope that was helpful. That's it. That is indeed a challenging one. I'll see you next time.